Stqs 1023 Statistics for Information Technology. Hi, my name is Chan Kai-en. Metric number is 27765. The title of today is Hypothesis Test for One Population Mean. So in this presentation, it contains three questions for hypothesis. Question 1. Question 1. The question is, the Food and Nutrition Board of the National Academy of Science states that the recommended daily allowance RDA of iron for adult female under the age of 51 is 80 mg mg. A sample of iron intake in was obtained during a 24-hour period from 45 randomly selected adult female under the age of 51. It revealed that the sample mean was 14.68 mg. At the 1% significance level, thus the data suggests that adult females under the age of 51 are on average getting less than the RDA of 18 mg of iron. Assume that the population standard deviation is 4.2 mg. So, step 1. Find the value of n, mean, and standard deviation. The n is 45, the mean is 14.68, and the standard deviation is 4.2. Step 2. State the null hypothesis and alternative hypothesis. The null and alternative hypotheses are: null hypothesis is 18 mg. Alternative hypothesis is less than equal to 18 mg. So it was a left tail test. Step 2. Decide on the significance level. So the degree of significance is 1%. The level of significance is 0.01. Step 4. Compute the value of the test statistic. So the formula is shown in here. So it is z equal to mean minus. So the formula is sample mean subtract the hypothesis mean and divided by the standard error of the mean. So it is 14.68 minus 18 divided by 4.2 divided by square root 45. And the answer is negative 5.3. Step 5. Type of the test. So the sign less than in the alternative hypothesis indicate that the test is left tail. Error in the left tail is 0.01. So the critical value negative z 0.01 is equal to negative 2.33 from the table 2. So this is the table 2. We can see that the 0.01 is placed under negative 2.33. Step 6. The value of z equal to negative 5.3 from step 4. So this is the graph. We can see that it is a left tail test. And step 7. Interpret the result of the hypothesis test. At the 1% significance level, the data provides sufficient evidence to conclude that adult females under the age of 51 are on average getting less than the RDA of 18 mg of iron. Question 2. So the question 2 is, a factory has a machine that dispenses 80 ml of fluid in a bottle. An employee believes the average amount of fluid is not 80 ml. Using 40 samples, he measured the amount dispensed by the machine to be 78 ml with a standard deviation of 2.5. So, question 1. State the null and alternative hypothesis. For the null hypothesis, it is 80, and for the alternative hypothesis is not equal to 80. So it can be more than 80 or less than 80. It could be left or right side. Therefore, we need to conduct a two-tailed test. Question B. At a 95% confidence level, is there enough evidence to support the idea that the machine is not working properly? So this is a diagram, this is the graph, and it shows that the error is 0.025. So for negative 1.96, it is a rejection area. So for the formula statistics test, it is 78 minus 80 divided by 2.5 divided by square root 40. The answer is negative 5.06. So the Z value is in the standard area, which is also the rejection area. So this tells us that we should reject the null hypothesis. Therefore, we could say that with a 95 level of confidence, we cannot accept the null hypothesis that the average amount of fluid dispensed by the machine is 80 millimeters. So, with the 95 confidence level, we believe that the machine is not working properly. Question 3. Using a 0.05 significance level, we are testing that claim that we are testing the claim that more than half of Americans admit to running red lights. We have a sample of 880 randomly selected drivers, of which 56% admit they run red lights. Obviously, in this study, 56% is more than 50%, but is it significantly more than half? A hypothesis test is a test of significance. So, step 1, the null hypothesis is equal to 0.5. The alternative hypothesis is more than 0.5. Step 2, find the critical value. The significance level is 0.05, so the critical value is 1.645. We can see from the table 2 graph. Negative 1.6 is placed under 0.05 is placed under negative 1.645, which is 0.0495 and 0.0505. So we can state that the critical value is negative 1.645. Step 3. Decision rule. We reject null hypothesis if test statistic is more than 1.645. Always reject the null hypothesis if the test statistic fall in the critical region, which is the shaded region. And step 4. For the test statistic formula, it is 3.56. The answer is 3.56. The mean is 0.56. Step 5. Reject no hypothesis. The sample data support the claim that most Americans admit to running red lights. So that's all from me. Thank you.